Okay, next. Okay, next combination logic circuits is here the 4-bit ripple carry adder. 4-bit ripple carry adder. Okay, adder. Adder means what the? It will add the many inputs. Okay, that will take the usually the two inputs. Okay, that is to be if the have the two inputs, it will be add the values here the through the bit to bit. Bit to bit, 1 bit or 2 bit, 2 bits. I need the addition of the any numbers. I need the 2 bits here. This is mainly for adder. This is adder mainly used in what the my arithmetical logical unit in the processor. No, you exactly what the adder. This is not used in the as the user daily users purpose will not use. Okay, real application developer will not develop. Okay, for the full adder, half adder, and all. Okay, this adder concept will be mainly used in the arithmetical logical unit. Arithmetical logical unit. ALU is the one unit which is present in the processor. The processor, that how it is to be carried out the some logical some operations, that is to be with the help of the adder. How the adder is working here, that one we will study here. But I will not bother about the completely how the exactly truth table and all. We studied the full adder in the previous class, that is in the DDCO. For the addition of the 2 bits, I will go with the half adder. Half adder. If you want to add the multiple number of inputs, so that's the 2-bit. Another one more input. That is the 3-input combination. 2 inputs as the inputs. 2 as the inputs. Another 1 input as the carry as the another input here. Carry as the another input. Then I go with what the full adder. First one, we'll see the how to design my full adder. Okay, just we'll see the how to design a full adder, not a completely. Will don't bother about the 4-bit ripple carry full adder. Just will design the full adder, 1-bit full adder. Okay, if I have the two inputs as the A as the B and B, that's the 7. This is what the 3. How to write the in the bitwise with the binary form, that's the 0 1 1 1. This is what the 3 has to be written is the binary as the 0 0 1 1. Okay, then we'll go with the addition of these 2 bits. First last 2 bits. Last 2 bits. First I need here what the gate here 1 half adder. I go with the second bit addition with the carry is coming here. Okay, for as the 1. So that I need the 3 bits. Half adder is only works with the 2 bits only. But with the if you want to go with the add the 3 bits, that's the with the carry also. Then I go with what the full adder. Then I go with the full adder. One more full adder I need here. One more full adder I need here. That means 3 full adder, 1 half adder I need here. Instead of giving the instead of taking the half adder itself separately, I can also put the carry as the 0 here, so that C1 as Cin as the 0 here, so that I can also replace this half adder with the full adder with the carry as the Cin as the 0. Cin as the 0. Initially, we will be used to design with the help of what the half adder, 3 full adder for the 4-bit combinations, 4-bit purpose. But instead of going with the separate half adder, I can also replace the half adder with the help of what the 1 full adder with the considering the input carry as the input 0 0 0. Initially 0. Initial carry any carry 0. That's nothing but the initial will set the input as the Cin as the 0. So in keeping in mind, first we'll start designing what the full adder. Will not only the will think about only the full adder. How to design the full adder? That is to be based on what the this combination. Okay, this is what the truth table there we have seen in the last semester. A, B, Cin, and the this is what the sum and the carry C out. This is to be done. Okay, these are the combinations I can have. This is what the 0 0 0. The sum is what the 0, carry is 0 0 0 0. Sum is 1, carry is 0 0. Sorry, 0 1 0 1 0. Sum is 1, carry is 0 0 1 1. Sum is 0, carry is 1 here. 1 0 1 1 plus 1 is how much? 1 0. 1 plus 1 is what? Binary values. 1 0. That's the sum is 0, carry is 1 here. So that I return the sum is 0, carry is 1. Similarly, I can also write the 0, sorry, 1 0 0, sum is 1, carry is 0, 1 0 1, sum is 0, carry is 1. Similarly, 1 1 0, sum is 0, carry is 1, 1 1 1, sum is 1, carry is 1. Okay, based on this, while referring this, these two columns, I return the sum as the A XOR with B, XOR with the C in. How I return that one to be based on what the sum is here. What are the sum? Wherever the 1 is there, that is to be considered as the input combination. A bar, B bar, C in. Like this, we have manipulated in the previous classes. While referring this, while doing this one, we got the two equations. One is what the sum equals to A XOR with B XOR with C in. And also I got the C out. C out is what the exactly the AB A dot B plus of C in multiply with the A XOR with B. We got with some manipulation we done with in the previous class, previous semester. While referring, we need about only the two equations. Sum as the A XOR with B XOR with C in. Another one is what the C out as the A dot B plus of C in dot of A XOR with B. We'll consider these two equations. While referring these two equations, we'll start designing of the full adder. Okay, full adder. How to design the full adder? We'll see. Okay, I need how many gates here? What type of gates here I need here? Just to see, you can observe. One XOR gate, second two XOR gate. Two XOR gates I need here. One AND gate I need here. Another AND gate also I need here. This XOR gate is similarly what the A XOR with B already is there. Just to make the jumps over here. Just to connect this XOR with this one. How to design that's to be done here. First, we'll consider the A XOR with B. A XOR with B hang madಬೇಕು. Sum I have to consider A XOR with B. XOR gate after first XOR gate. What are the inputs for this XOR gate? First input is what the A. Just to send the A. Another input is what the B. Another input is what the B. The third input is what one more. Okay, C in is there also. I need the I put the one XOR gate, one more XOR gate here as this. And this one is the input. What is the input for the second XOR gate? Another one more input is there. Just I'm taking this one as the one more input. C in tonda. Then that is the output is what the sum is there. Sum output is what sum. Exactly what we are designed here the sum. Okay, sum equation. Sum equation I designed with the help of the two XOR gates as the inputs as the three inputs here. Similarly, I can go with the what the second equation, that's the A dot B is there. A dot B is nothing but the I need which type of gate I need here? AND gate. So that I'm considering the one AND gate here. Inputs as the what the A dot B. A dot B means what? One more time I will not take. I am adding this one as taking the jumps here. Wire connections. Older one. Okay, this is what the A dot B. This is what the A dot B. Now I go with what the one more OR gate I need here. What is that? OR gate. Just I am sending the OR gate here. Okay. Okay, this that's I can have the this is what the equation. Okay, this is what the A XOR with B. A XOR with B is where is the A XOR with B? Here only. A XOR with the B. I have to take this as the input here. Next input combination, I am taking as the input combination. And the C in dot C in. Where is the C in? C in is here coming. Okay, just to take the C in. What is this one? Dot product. Dot form is there. Dot form means also product form is there. One AND gate. One AND gate here. So that while referring this one, I have to design this one as the inputs to what the one is what the C out, that's the A with the B, and the Cin is there. Just to taking the these two what the as the inputs as the one OR gate I need here. This is what the C out. This is what the C out is there. Okay, in the book, your reference book, he has given the this is XOR gate. He has mentioned the XOR gate, but it is right with the OR gate itself is right. Okay, this one you refer it. Okay, this is what I'm getting here. This is what the C1, that is the carry is there. This one can be renamed as the connection between the gate to gate. What is that? We can give the name as the this is what the S1. First XOR gate to another XOR gate, this one calls the wire. That was named is what the S1. Another one is there connection between the one gate to another gate as the this one as the C1. This one as the C1. Okay. Another one more line is there. That's the gate to gate connection. This one can be given as the C2. This one can named to as the C2. Okay. This is what the full adder designing of the 1 bit full adder. What we designed here, the 4 bits I need here. 4 bits means 4 full adder I need here. But I designed with the 1 bit, first 1 bit. Book ಅಲ್ಲಿ ಏನು ಕೇಳ್ತಾರೆ 1 bit full adder ಅಂತ ಬರೀತಾನವ. 1 bit full adder ಅಂದ್ರೆ ಏನು ಫಸ್ಟ್ ಬಿಟ್ ಅಂತ ಅರ್ಥ ಅದು. 1 bit ಅದು ಹ್ಯಾಂಗ್ ಆಡ್ ಮಾಡ್ತಾನಂತಲ್ಲ ಫಸ್ಟ್ ಬಿಟ್ ಇದೇನದ 0 1 1 1 0 0 1 1 ಅದಂತ ಇಟ್ಕೊಳ್ಳಿ. ಫಸ್ಟ್ ಬಿಟ್ ಎಡಿಷನ್ ಏನದಲ್ಲ that one he calls the 1 bit one bit full adder. Second is ತಗೊಂಡಾಗ ಎರಡನೇದು ಮೂರನೇದು ಈ ತರ. I need how many 4 bits. First bit, second bit, third bit, 4 bit. That one we need what the 4 bit ripple carry adder. RCF. Okay, RCA. This means what the 1 bit full adder I designed here. How many bits? Only 1 bit. I need how many here? Like this I need the 4 bit. 4 full adder I need here. That's nothing but the 4 bit full adder. That's nothing but the 4 bit full adder. Just to write the program, structural or gate level model for the this structure, this one. Okay, start writing the program of your own. Try to write. I'll be writing that program also. Okay, try to write. What is the full adder name here? You can give the name. Okay, well, write the program here with me. Okay, that's the module. Full adder name can be here the FA. Full adder ಅಂತ ಬರೀರಿ ಪರವಾಗಿಲ್ಲ. ಏನು full adder. ಇದು ನೆನ್ಪಿಟ್ಕೋರಿ ಏನು ಬರ್ದಿರ್ತಿರಲ್ಲ this one has to be using everywhere. Okay, this one I'll be using the everywhere. This one I'll be using this module name as everywhere while writing the further programming. Just to what are the inputs for this one? Just to output is what are the outputs here? Just to identify output, which are the outputs here? Sum and the C out. Write it off your own. Sum and the C out. Okay, I'll tell the input, output or what are the sum and the C out. Okay, inputs. Which are the inputs here? Manju, which are the inputs here? AI and wires. Wires ಯಾವ್ಯಾವ S1 ಅದಪ್ಪ ಆಮೇಲೆ C1 ಅದ C2 ಅದಾವ ಇವು ಮೂರು ವೈರ್ಸ್ ಅದ ಔಟ್ಪುಟ್ ಯಾವ್ಯಾವ sum and the C out. While referring the inputs, output and also wires, just to write the program. Module name can be here full adder. First I have to write the mention the outputs here, sum and the C out. Input, what are those inputs? A, B, C in. Okay, over. Now the input, which are the inputs here? The A, B, C in. Output, which are the output here? Sum and the C out. Okay, now the wires. I have to define the wires also. Interconnection between the gate to gate connection, we call them as the wires or connectors ಅಥವಾ wires ಅಂತ ಕರಿತೀವಿ. ಇಲ್ಲಿ ಏನು ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ? Wire ಅಂತ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ. Wires ಅಂತ ಬರೀಬಾರ್ದ? Wire ಅಂತ ಬರೀಬೇಕು. Wire. What are the wires names here? S1, C1, C2. S1, C1, C2. Okay, done. I done. Okay, next is what the writing. Okay, identify the gate names here. What are the gates here? Just to look at here. First XOR gate, second XOR gate, first AND gate, second AND gate, one is OR gate. Just to name them as the XOR gate, XR with the, you can give the any name, instantiation purpose as the X1 only give. First input say output ಏನದ ನೋಡ್ರಿ ಇದಕ್ಕ S1 ಅದ ಫಸ್ಟ್ ಔಟ್ಪುಟ್ ಬರಿಬೇಕು ಫಸ್ಟ್ S1 our inputs ಏನದವ A, B ಬರಿಬೇಕು. ನೆಕ್ಸ್ಟ್ ಸಿಮಿಲರ್ಲಿ ಐ ಗೋ ವಿತ್ ದ AND ಗೇಟ್ ಬರೋಣ ಆರ್ XR ಗೇಟ್ ಬರ್ರಿ ಯಾವ್ದಾದ್ರು ಬರ್ರಿ. ನೆಕ್ಸ್ಟ್ ನಾನು AND ಗೇಟ್ ತೋತೀನಿ ಅದ್ರ ಕೆಳಗಿಂದ AND ಗೇಟ್ A1 ತೋತೀನಿ. ಇನ್ಪುಟ್ ಔಟ್ಪುಟ್ ಏನದ AND ಗೇಟ್ದು C1 ಅದ ಇನ್ಪುಟ್ಸ್ ಏನದವ A, B ಅವ. Okay, similarly I go with what the sum out this what the first XR gate, this what the second XR gate XR with the X2 ಏನದವ ಇದಕ್ಕೆ ಔಟ್ಪುಟ್ ಏನದವ sum ಮತ್ತೆ ಇನ್ಪುಟ್ಸ್ ಏನದವ S1 ಮತ್ತು Cin S1 ಮತ್ತು Cin. Okay, done. Okay, next is what the second AND gate, that's the AND A2. AND gate ಗೆ ಏನದವ ನೋಡ್ರಿ ಇನ್ಪುಟ್ಸ್ Cin ಅದ Cin ತೊಗೊಂಡಿವಲ್ಲ ಇಲ್ಲಿಂದ ಕನೆಕ್ಷನ್ ಮಾಡಿದೀವಲ್ಲ Cin ಒಂದು S1 ಒಂದು ಯಾವ್ದದವ ಔಟ್ಪುಟ್ ಏನದವ C ಔಟ್. ಇನ್ಪುಟ್ಸ್ ಏನದವ್ರಿ Cin ಮತ್ತ C1 ಹೌದಲ್ಲ S1 ರೀ S1. Next is what the one more gate is there. What is that gate name? Vinod, one more gate is there. Where is the OR gate here? OR gate ಯಾವ್ದದ ಇದ ಯಾವ್ದು OR gate ಯಾವ್ದು ಇದು ಯಾವ್ದು ಯಾವ್ದು ವಿನೋದ this one okay, good. Okay, next is what the OR gate. Just to write the OR O1 insertion. Okay, output ಏನದ OR gate C out ಅದ ಇಲ್ಲರಿ ಇದು C2 ಅದ ಇದ್ರದ್ದು C2 ಅದ ಇದು ಏನದಮ್ಮ C out ಅದ. ಇದು ನೆಕ್ಸ್ಟ್ ಇನ್ಪುಟ್ ಏನನ್ನದ ಇದಕ್ಕ C2 and the C1 and C2. This is what the end module. Just to write the end module also. This is what the writing a program for the 1-bit full adder. 1-bit full adder ಆಯ್ತು. ಇದು 4-bit full adder ಕೇಳ್ತಾರೆ ಎಕ್ಸಾಮ್ ನಾಗ. 1-bit full adder ಬರ್ದ್ರಿ ಈಗ. Next you just to call this one, okay, as the inheritance. Okay, as the inheritance, our Verilog HTML also supports for the OOPS concepts. So just to call this name as the another program, one more program right there. Just to call. How many times should I call this one? 4 times, because I need the 4-bit triple carry counter. I have to design here 4-bit triple carry counter. How to design this one? Just to see. Just to copy that one. Okay, this is what the designing of the 1-bit. I need here the 4-bit ripple carry counter, so that 0 1 1 1 one input has the A, second bit input has the 0 0 1 1 is there. For example, I am considering example, always I am taking this one only. Just I did here what the designing of the first full adder, only the half adder, second full adder, third full adder, fourth full adder. I need here a 4 full adder. How to design it one? Just to take the 4 full adders. First full adder is what the 0 1 1 1. Second is what the 0 0 1 1. For this one, I can designing. Okay, I can have the 2 input combination of the combinational circuit. Which one is the half adder? Here, how many? Which one I can go with the half adder? For the carry, for the 3 inputs adder is there. 3 inputs adder. Which one is the 3 inputs adder? Full adder. How many full adders I need here? 1 2 3 full adders I need. 3 full adders, 1 half adder. Just to design that one, half adder, full adder, full adder, full adder. What are the inputs for this one? What are the inputs? A0, B0. A0, B0. Second is what the A1, B1. Shantesh, good equal. Third input is what that? A to B2. Third one is what the? Fourth one is what the? A3, B3. Output is what are the output here? The sum. Sum is what is that sum? S0, S1, S2, S3 is here. Okay, always carry. My carry is propagating from here as the C0, C1, C2, C3. Okay. Okay, sorry, C1. Okay, just to take the C1, C2, C3, and this